Howdy, my name is Sarada Sawansatit, and I'll be giving a presentation on how to use the Slurm scheduler on the ACES cluster. So first thing first, let's get on the website, hprc.tmu.edu. I will be guiding you on how to access the ACES cluster. This process will require you to have an access ID. So let's get on to the website right here and navigate to portal and then ACES portal right here. I'll give you some time to do that. Alternatively, you can also go on portal-aces.hprc.tmu.edu. If you don't have an access ID or some credentials that allows you to log into ACES, please raise your hand. Once you get on the website, you should see this page where it prompts you to select an identity provider. If you are a TMU user, you can select Texas A&M, else you can select ACES CI. Once you are on this page, you can navigate to clusters and shell access. Shell is also called terminal or command line. I will be using these terms interchangeably throughout the presentation. So let me navigate you on to the website. First, I go on hprc.tmu.edu. Then I go on to portal and then ACES portal. So I am a Texas A&M user. So I will be choosing Texas A&M. Then I will provide my net ID. And now we are done with this hands-on activity. Let's go to the next slide. So currently in your shell, so we are now in the shell. You are on the login node, as you can see. So the difference between the login node and the compute node is that the login node is for light editing and viewing files, activities such as that, while the compute node is for heavy computation. So when you require a lot of computational powers, you want to get from the login node to the compute node. So how would you get from the login node to the compute node, you might ask? And that's where the batch scripts come in. So the batch script is a text file that defines a job. It contains software commands and batch parameters. So when you submit a batch script, you will submit a job, and the job will be queued by the Slurm, in the Slurm, which is our batch manager, and it will allocate the job into one of the compute nodes. We also have a tool that assists you on how to do this. We call it the DRONA Composer. So on the portal, you can navigate to jobs and drop-down menu, and then you can click on DRONA Composer right there. So once you're here, you can select your environment or add modules, and also you can also specify the number of cores/tasks and number of nodes. I will explain what these parameters means later in our presentation. You also can select your accelerator and specify the total memory and the expected runtime. Let me show you on. So we're here. I go on to ACES portal. And then go to jobs and then DRONA Composer. So right here is the DRONA Composer. I can type in some name and choose a generic, which is the default. I can choose to upload a file if I needed to. So also choose to add modules. And you can hover over these question marks to see what they means. And these two parameters I will explain in the later slide. So for example, in the modules, I can choose to add Python right here. And I can choose an accelerator or GPU. For my tasks, I decided not to use a GPU. And I can specify the number of total memory, which is 4 GB should be enough. and I choose simple 10 minutes. And here is what your batch script will look like. So let me explain what batch script. So this is the structure of the batch script you just generated from DRONA Composer. So right here is where we specify the job name. This is where we specify the runtime, the wall time. As you can see in our sample, we specified 10 minutes or 2 minutes. Yes, 2 minutes. And it appears right here. And right here, they specify the number of tasks to be 2, and tasks per node to be 2, and node to be 1. And they specify their memory to be 3 gigabytes. And this is where their output will appear. So this is where the modules we added will appear and our commands. You can find more information on this on our knowledge base, which is hprc.tmu.edu/kb. Let's do a hands-on activity on how to customize your DRONA Composer environment. First, let's start by creating a directory on the directory called DRONA Composer, and in that directory, create an environments directory. So let's do that. I will just demonstrate. So let's go on our file manager. So let's go on to our Scratch directory. And on your page, it should say scratch/user/your username. And let's create a directory called DRONA Composer. So DRONA_Composer. Then we can double click right here to get into the directory and create a directory called environments. So right here. So now let's copy a generic environment into this directory. So first we have to go into Scratch training/Slurm schedule to this directory right here. So I will demonstrate on how to do that. So you can change your directory right here. So Scratch training/Slurm scheduler. Here. And you should be able to see this page. Then I will copy the generic environment with this button. Then I will navigate back to my Scratch in DRONA Composer, and then environments. Then I will click copy. Let's go on to the next slides. So now you can edit your schema.json file inside my generic. This is how you do it through command line, but I will show you how to do that through the GUI. So see here, you have the schema.json file. You click on the 3 buttons right here and go on edit. And you should be able to see these files. So currently on the DRONA Composer, if you go back to the DRONA Composer page, which is, you can reload it. on the dashboard, it should be under jobs and then DRONA Composer. Just type the name and you should be able to see the My Generic environment that you just copy. And it should be the same as generic. So we'll modify it a little. So now we have, yes, so right here, let's edit the schema.json file. Click on edit and you should appear on this page. So we can edit a file. For example, if I'm a user who doesn't really use GPU, I will just remove this. It's easier for me to not select any options at all. Over here. Then I will save. Oh. Then I would go back and reload and my generic. And I shouldn't be able to see any options other than none. And as normal, I can add my modules. And specify everything. And be able to get onto this page. So it should function as normal. So this is just an optional activity on how you can customize your environment to the way you want. So as I explained before, in our JavaScript, you have the time, in specific time, using this, number of cores or tasks using this, and the number of tasks per nodes or number of memory. You can also specify them in megabytes using M instead of G, and the number of nodes. So these are the visual presentation of how cores are mapped, of jobs to core, how jobs are mapped to cores. Excuse me. So right here, each green squares represent 1.5 cores. And on our ACES cluster, we have a total of 96 cores, aka tasks. And here, if we're using one node, we will be mapping all 96 tasks or cores onto that node. You can also split your your number of tasks into multiple nodes by this. So now each node will be each core your tasks, all your tasks will be mapped into two cores. So no, I'm sorry, two nodes, and each node will have 48 tasks. And example C is how you can map your tasks into 4 nodes. So it should be 24. I see that we have a question. Do I need to apply for HPRC SUs to be able to use to run jobs on ACES? For that, you have to get an account through ACES, and we have some information on that in our knowledge base at hprc.tmu.edu/kb, and you can navigate to a page called Quick Start on ACES. Time for some pop quiz. So how many cores is this job requesting? And here is the job parameter. Hint, I suggest you look at this 3 lines right here. Most of you answered 4 cores. And that is wrong. You have 4 nodes, but you have 96 tasks. The 96 tasks is the same thing as cores. So let's go back to the previous slide. So as you can see here, we have 96 cores, but they're also called tasks, right? So the correct answer is B, but you're actually mapping the 96 tasks or core to 4 nodes. And I think that is where the confusion might comes in. As you can see, this batch parameter is matching to our example right here, example C. We have 96 cores in 4 compute nodes. And you have 24 cores per node, since it's 96 divided by 4, where it appears. Yeah, so 96 tasks equals 96 cores. So these are the commands you can type within your shell to, for example, submit a job. So sbatch and the name of your job file. You have sq, just your username and job ID are the parameters, which you can list the jobs that is currently running in your account. So do scancel to kill your job. This to check the information of your job, sact, and you can use this to show the information of all your jobs since it's been submitted. We'll be having some hands-on activity on using these commands later on. You can reference your jobs using some variables right here. So for example, this means your job ID. This means the directory where the job was submitted from. And as you may remember, in our job composer, DRONA Composer, your directory will be submitted from your scratch/job composer, which is temp directory, and here's your scratch directory. So scratch/user/username is where we put our DRONA _composer directory in. So this is basically how you submit a job. So after you run the sbatch command, okay, I have a question. We have a question. So when will we use the temporary directory? So the temp directory is usually used when you want to see some quick output. And by that, when you put it in here, when you specify it in the from what I've seen, users usually specify the temp directory as an output. So that means that the output will be like really small. So you can use that for that. And here's the SQ and what the output would look like. As you can see, the job ID matches the job ID that is submitted, that's created by Slurm. And you can use the file navigator, which I went over. So here's a little hands-on activity on submitting a job. Let's do that. So first, let's go onto the portal. See, it asks us to go back to the Scratch training Slurm scheduler. So let's go back there. And you should be able to see this page. And the guide asks us to locate some files called hello world.py and hello world.slurm, and copy those files into the home directory right here. And this is optional. You can edit your Python file. And you can also open a terminal to edit or tinker with the files. All right. So let me go back and demonstrate on how to do that. Currently, I am in Scratch training Slurm scheduler. Then I will copy these 2 files and then go to my home directory and move the files here. As you can see, I got that error because I already copied these files right here. So that's why I got the file. Then it tells us to submit a batch file using sbatch. So let's go on to our terminal. Right here, we go on to clusters and ACES shell access. And currently, I am in my home directory. I will type ls to see what files I have. And as you can see, I have the hello world.slurm here. So I will type sbatch and hello world.slurm to submit my job. And it should work. So here you can see that I have successfully submitted my job. And we can refer back to the first slide where we have all our commands. Type SQ, then your username, -u, your username, then -j, your job ID, right? I will use that. SQ -j, my job ID, which is listed right here. Oh. And as you can see, the job is currently running. This job will take roughly 5 minutes to complete. So in the meantime, I will be explaining some other slides. So we also have other commands that you can use in our shell. So for example, we have the license status command, which will show us all the license softwares that we have and the ones that is currently available. So let's try to use that. License _ status -s. And let's see, we have use -s to see what we have available. Oh, sorry, -out. Simple, we have a MATLAB right here. And we can use -s to list, to check the status for me. So -s, MATLAB. As you can see, we have 50 issued and we have 50 available. And let's check out the progress on our job. Here it's still running. It's been running for 2.5 minutes. And see, we have job ID here, we have your job name, your username, and the partition of CPU, and the number of nodes in CPU, and also the node list. So this information can also be found on our job listing page. Let's show you right here. Oh, it looks like it's not working currently, but there's an alternative way to see that. So we have jobs, also active jobs. As you can see, we have this job is running. Right. So how does Slurm assigns job? Job submissions are auto-assigned to batch queues, which are called partition. As you can see in our job, our partition is CPU, and it really depends on the number of cores / nodes that you requested. Some jobs can be directly submitted to queue, which, see right here. And your DRONA Composer automatically assigns the job. And you can check the status of the nodes / partition. You see sinfo. And you can see that the currently available partitions. And you can also see these variables on our portal right here on our dashboard. this is the same information you can see. So in our shell, you have A, which is available, I, which is idle, and O, which is information you can find right here on our slide. O stands for offline, and T is for total. And you can also use a PEStat command to check the status of the nodes on ACES. And you will have to specify a partition. For example, this one they specify the GPU on the status of the job. Looks like our job is completed. And let's check on the output of our job. And it should be under job in our, home directory. So as you remember, my job ID was the 237600600. And this is my output in our .slurm file. How to check the output? Right. I will demonstrate in the command line, via command line also. So we have Alice right here. And you have to see this is one of the output that I got. So I can also cat that file. Since we, in our Slurm parameter, we specify the output to be in the same directory. In our slide that we've shared with you guys, we detail some commands that you can use to check for various resources on our cluster, including like my project, and you can specify your account right here. And they also should be listed on your dashboard, which I showed you. And this is our planned charging scheme. You can find more information on our YouTube page, or just simply type TamView as HPRC YouTube. You can find these videos right there. The ACES quick start guide over there on our knowledge base. And if you're running into problems, you can email us at help@hprc.tmu.edu. And when you email, I suggest you include the cluster name. For example, we're using the ACES cluster, your username, your job ID if you have one, and the location of your job file, include both input and outputs. And any applications you're missing, any module loaded, and your error message. And thank you.